Hello everyone and welcome to the next Python video. In this video we'll introduce a new topic, which is getting input from files. So the goal of this video is to introduce how you read data in from a file. We're going to do two examples. In the first example we will read in numbers from a numeric data file, so a data file with numbers in it, and calculate the average and standard deviation of those numbers. Secondly, we will read in strings from a file containing words to check and see if a given string is in that file. In other words, I have a file with words in it, and then I have a particular word of interest, and I want to see if that word of interest appears in this file somewhere or not. Okay, so we'll just do two examples to give sort of a basic introduction as to how you would get something from a file and then do something with it, right? Get numbers and then take an average or standard deviation or whatever it is you might want to do to those numbers. So just to motivate why you would care about this, let me just recall a program you've written already. So you've already written a program, right, that calculates an average or a median or a standard deviation of some numbers, but the way that program worked was that to get the numbers, the user entered them one at a time. So the user entered number one, like number one, enter, number two, enter, etc. Or number one, space, number two, space. And so, of course, in any sort of real application, that's not how you're going to get your data, right? You're not going to have people enter numbers one at a time because for most practical applications, the data sets are really large and it would take forever to type them. So just imagine, right, that you wanted to calculate the average home price in Kansas City. Well, that's a data set with like 100,000 numbers in it, so you're not going to enter those numbers one by one into your program. That kind of data is stored in an external file somewhere, so what we need is a way of having our program grabbing that data and then manipulating it. So that's what this video is about. So in particular, we're going to start fairly low level. The files we're going to be dealing with are pretty stripped down. There's not much in them. So how do you access a file? Well, first, you need to make sure two things are true. And I guess I should say you need these two things to be true for us right now in this class. There are, of course, other ways you can get around these things I'm saying, but for us right now, what we need are these two things. You want the file that you're trying to get access to be in the same folder on your computer as your Python file. So if your Python file is on your desktop, then this folder you're trying to open needs to also be on your desktop. Furthermore, the file should be in one of these two formats, a text file, so usually a .txt, and sometimes you can do a .rtf on a Mac, or a CSV file, which is just basically an Excel spreadsheet that's been saved in a certain way. So again, it's not like you always need this to be the case, but for us at this starting point, you need those things. Given those things, here's how you gain access to a file called numbers.csv. So there's just a command called open. And when you use that command, basically what you're doing is creating what's called a file object called myfile, which essentially is a version of that file, but that is now living inside your program or living inside the compiler that you can manipulate. So my file here, and you can use whatever name you want, but my file is basically the file numbers.csv just within your program so that you can do things with it. So you have to do open and then the name of your file in single quotes and then comma, and what comes after the comma is called the access mode, like how you want to access this file. There are different things you might want to do with the file. R stands for read, like just read in the data and nothing else. You can imagine doing other things like writing information to the file or overwriting information inside that file. Whatever. Just for now though, comma R tells the compiler that we are reading in the data, we're not changing the data or something. After you've opened the file, you can access individual lines of the file with a command like this. So assuming the file object is called myfile, you can then save all of the lines in another object. And again, I should say that names are arbitrary. You don't have to call it myfile lines. It's just a descriptive name. and the command is .readLines. So read lines is what gives you access to all the lines of a file. So let's just go over to the compiler and see how that command works and what it's doing for you. Okay, so I have numbers.csv is the file I'm interested in, and this file is on Moodle. It's just a file with like some numbers in it, and there are only 18 of them. Okay, so it's not a particularly interesting file, but anyway, it's up on Moodle. So this open command gives me access to the file via this file object that I'm calling numbers file. And then I do numbers file.readLines, and I put that in this file lines object right here. And let's just see what that is. So I can ask the computer to print file lines. So I couldn't ask the computer to print like numbers.csv, you know. The computer won't know what to do with that. But it does know what file lines is because I've now done these commands to give it access to those lines. And here's what it prints over here, okay? Notice it's thinking of file lines as a list. You can tell that from the square bracket notation. And then there are the numbers that are in that file, right? 10, 14, 23, etc. So notice, right? You've gotten access to that data. That data is living in this file, which is like not in your compiler originally, right? It's its own separate thing, but you now have access to it. Notice, though, that these numbers are actually not being thought of as numbers right now. So the quotes around each individual element means the computer is thinking of these as strings, not as numbers, which might be problematic. Also notice the /n's everywhere, okay? So a /n is a new line character, like as if you've hit the enter key, which makes sense given that these numbers are on individual lines of a file, right? So this 10 here is actually like 10 new line to give you now down to a 14. And then 14 new line hops down to 23. Okay, but anyway, you have the data, right? If you want to add them up or subtract them or whatever later, you're going to have to deal with the fact that there's strings with these new line characters attached, but you have the data. Okay, so once you have it, now if you want to do things with it, let me uncomment a lot of this code. So I just want to calculate an average and standard deviation. Get rid of these quotes. Okay, so to calculate an average, you do what you normally do. You got to add up all the numbers and divide by however many there are. So sum 1 here is going to be that sum of the numbers, and count 1 is just going to be a count of how many numbers there are. And so notice at the bottom here I have average equals sum divided by count, right? So how do you add up these numbers from the file? And how do you count how many there are? Well, notice you can set up a for loop that just iterates over file lines. The same way you can iterate over any list if you want to. So x here, as x changes, is just becoming each element of each new line. So x starts as a 10, then becomes a 14, then a 23, etc. You're just walking over those elements. And every time I do that, I up the count by 1. So that gives me a count in the end of how many lines there are. Notice this next command, which we haven't seen before, right? What is this doing? X equals x dot strip. The dot strip is taking away this new line character. Okay, so instead of 10 new line, x, the individual line, will now just be 10. Okay, which is what you need if you want to add things, because it makes no sense to add numerically, 10 new line plus 14 new line. What does that mean? Okay, and then once you've stripped away the new line character, now you need to make sure that for like numeric addition, the computer is thinking of that individual line as a number. So I've cast it to float here to make sure it knows it's a number. So stripping and then casting to float treats the lines as you want them to be treated, which is as numbers, not as strings with new line characters. Okay, so now down beneath, as I scroll down a bit, this next for loop will calculate a standard deviation. So again, I'm going to iterate my way through file lines. I'm going to count up how many lines there are. I suppose I didn't need to do that again, but whatever. And again, I need to strip the lines of their new line characters, and then every time I want them to be treated as a number, I have to tell the computer, hey, this is a number. But each number, what I do is I subtract it from the average, I square it, and then in the end, the standard deviation is all that sum divided by, now here it depends on which formula you're using. I'm using the one that takes 1 off the count, but you could do this if you want to use the other definition of standard deviation. Some of you have done that before. Either way is fine. You just pick which formula you want. And anyway, once you've done that, right, now these numbers that were living in an external file, you can just grab them and learn things about them, like what their average and standard deviation are. So notice I have this print command, right? Print and standard deviation. You can check, if you want to, that the average of these numbers is 38.3 or so, and that using my definition of standard deviation, it is around 20. Okay, so that's how you can get access to at least this kind of numeric data, right? Just number, 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 all the way down in a single column of a CSV file. Before moving on to string data, I just want to point out real quick, so all this sample code, in addition to these number files and the next string file, this is all on Moodle in the sample code section, so you can play around with this yourself. This next chunk of code, it does the same thing, it's going to compute an average and a standard deviation. I include this code just to point out to you that files can be handed off. File objects can be handed off to functions if you want to. So this top function here, file average, you can feed a file into that if you want to. And then you can, once it's in there, you can read the lines and do the same thing we've done before. Okay, so you can feed file objects into functions, and everything works just fine. Notice there's this additional command here, though, that you didn't see from the last chunk of code, this file.seek 0. The reason that's there is because if you start using this read line commands more than once, and notice I have two separate functions, right? So I may well call on both of them, meaning I'm doing this read lines command twice, right? Once in the first function and once in the next function. When you use read lines more than once, you can get into trouble because the first time you do read lines, you read all the way through the file, and now it's like your cursor's at the end of the file or something. Where you're looking at in the file is at the end now. So if you do a read lines command again, now you're at the end and you don't see anything. So if you're worried about using this command more than once, you should always do this command first. This just resets the cursor or the search button. I don't know what analog you want there, right? What analogy you want. It just makes sure that you're starting your look at the beginning of the file. So at line 0. Okay, so these two functions are not going to run interference on each other with where you're looking in the file. Otherwise, this code is exactly the same. I just took those two tasks, the task of computing an average, the task of computing a standard deviation, and I've thrown that code up into a function, and I have a file object now that I'm feeding into it. Okay, so functions play nicely with files. Okay, so one last quick example here. So we did this, right? We calculated the average and standard deviation. Now I just want to switch to text files. So what if you have a file with words in it, or strings in it, rather than numbers? And to motivate this example, I want to use the game Text Twist, which was a popular game back when I was in college, online. And the way it worked was the user was shown 6 letters, and they had to find all words they could using those 6 letters. With the exception that the game didn't care about words of length 1 or 2. Okay, so you had to have at least 3 letters in your word. But anyway, so the user might be shown A-Y-T-H-R-E, and you would enter things like H-A-Y, hey, they, hat, and so on, right? So if you were to write your own Text Twist program, and you start thinking about what kind of tasks you need that program to do for you, one task that I think obviously presents itself is that when the user enters a word, you're going to have to check that it's a real word. So if the user enters THR, you have to tell them that's not legal. I'm not counting that. But when they enter HAY, right, you have to count that. So the question is, well, how could your program verify that a user entered word actually is a word? And I don't know, there are maybe many ways you could do that, but one sort of obvious way that presents itself is, well, what if you had a data file with all English words of length 3, 4, 5, or 6 in the file? Well, if you had a database like that, right, then every time a user entered a word, you could just check and see if that word was in that file or not. And if it's not, right, then you don't accept the word, but if it is, you do accept the word. Now, as you can imagine, what I just suggested might be wildly inefficient, right? That might be kind of a slow thing to do, but let's not worry about that, right? Let's just think about, you have this file out there of all these English words, and you want to check if what the user gave you is in there. So on Moodle, again, in the sample code section, I have this text twist words file, and I can't really vouch for this, okay? Like, I don't know if like Scrabble judges would agree with all these words, but supposedly this file has all legal English words of length 3, 4, 5, or 6. So like abacus, you know, that's a legal word. Aback, right? What? Abase, abased, abases, right? Whatever. So anyway, when the user enters their word, let's check it against that file. So here I've started that program. So text twist words, let's create a file object for it in Python, and then get access to the individual lines. And suppose the user enters hello, right? And now you want to check if that word is legal or not, or just checking if it's a word. Now, as you can imagine, there's another task you might need to check, right? What if the scrambled 6 letters don't contain 2 L's or something, right? But we're not worried about that right now. We're just focused on, is this thing they gave us a word or not, right? You could check later if it actually came from the letters presented to them. Okay, well, you can just set up a for loop again, words, lines, and just check to see if you ever encounter a hello. So maybe it's more descriptive to say this. So for word, like each individual line of the file is a word. We're going to have to do the same thing we did before, where we strip off the new line character. If you don't strip off the new line character, now you're checking hello against possible hello with a new line character, and it won't get a hit. It won't detect a hit off of that. But now each line is just a string that's a word without a new line character. And now you can say something like, well, if word equals user word, that hello, right, then do whatever it is, right, you want to do. Legal word. Okay, so what this will do is this for loop will go over every single line in the file, so every word in the file, and just check if the user word equals some word in there somewhere. So I run this and it says legal because hello is in that file. So again, this is not particularly efficient, but you saw how fast that ran, you know. There actually aren't that many English words of length 3, 4, 5, or 6. So you can actually do this pretty quickly. So now let me just type something that I hope is a garbage word, right? Surely that's not a word. If I run that, notice it prints nothing, you know, because it didn't find it. So if you want to make this a little more elegant, you could say something like found equals false. And then like if you ever find it, you should change that value to, oops, found equals true, like that, right? And then down here you could have something like if found equals true, print that's a word or whatever, right? Else not a word, something like that, right? So let's just run this. Whoops. If, I lost my colon. Right, so XXFRD, it told me it's not a word, you know. It didn't find it inside of that file. Okay, so this is how you access data files. At least they look like this, right? Just lines of things like this. So as you can imagine, data files in general get more complicated. So imagine a spreadsheet with column 1 being a certain kind of data, column 2 another kind of data, column 3 another kind of data, and so on. We're going to need something more sophisticated to parse all of that, right? But this is a start point. You know, if you just have a spreadsheet with a column of numbers, you can do things with those numbers. If you just have a text file with a column of words, you can analyze those words. So that's a good enough introduction.